Okay, so now we're going to think about, instead of moving this by affecting the acceleration like we did in the previous videos where we had random acceleration or constant acceleration or acceleration towards a target, we're going to think about how to affect our movers by applying forces. And we're already set up really well to do that because we already have force equals ma. So we just need to do something with force and then have it affect our acceleration that way, and then our acceleration will affect how our mover is moving. So we need to do something like that instead of this. We need to do something with applying forces. So let's make a definition down here. Apply force, and we want to pass in a force, and that force is going to be a vector. Okay, so here's basically what we want to do is acceleration. We want to affect the acceleration. So F divided by A, F divided by M is just the same, this same equation, but where M is divided by both sides. So let's, to do this, we need a mass. So let's put in a mass up here, self dot mass equals mass, and we want to have it so we can change the mass size, or we don't have to put in a variable for this. So this way it'll be initialized as 10 if we don't specify it when we are creating our mover. But if we don't want to, if we don't want to make it specific, it'll just, this is the default, is 10. So now that we have a mass, we need to think about how to do this in code. And force is a vector and mass is a magnitude. So the way we're going to do that is so you can see that this is the same thing as that. So a vector scaled by 1 divided by mass is the same as vector, this up here, force divided by mass. So that's how we're going to do it, and we're going to say this acceleration equals rs dot vector scale, and we're going to pass in a force. We're going to pass in our force, and then we're going to scale it by 1 divided by self dot mass. Okay, so that gives us this acceleration. And so the reason I did this acceleration and not self dot acceleration is we're going to we want to be able to apply 20 or 2 or 3 or 4 forces. And so if we do it by self, then it's not going to be able to keep track of all those. So hopefully what I just said will become more clear now that I do this. If I do this self rs dot vector add, and we're going to add this acceleration to self acceleration. So now we can call this multiple times. Like for instance, if we want to do m dot apply force wind, m dot apply force gravity. So the accelerations that we create here and here will be added to the self-acceleration. So that way we can have both of these forces applied instead of Yeah, so we can have both of those forces applied. And so because we do that, we need to reset our acceleration every time. Okay, so one important thing to see here is that we had the acceleration do something right here, and so it did that before this code right here. And so we just want to be sure to apply force before update. So it does this before this, just like we had this before this. Okay, so we've got wind and gravity here. So to apply those forces, we need to have those forces. So we're going to make wind, and we're going to go, I don't know how well these variables work, but we'll try them out. And if they're too fast or too slow, we'll change them. And gravity, we're going to go x0, y0, and then negative 0.1. And before we test that out, let's just test gravity first to see what happens. Okay, so it's moving down, which is what we want it to do. It's moving down pretty slow, but it's picking up, I guess, a little bit. And you can see up here that it's slowly creeping, and that is because of that we had it initialized. We gave it an initial acceleration of this right here. So if we give it initial acceleration of 0, 0, 0, let's test that, and I don't think it'll creep now. Yeah, so now it's not moving in the XY position, it's only moving down. So let's stop right there while we have this working the way we want it, and I'll come back in a second.